almost done with chapter 3. So, what we have left is 3738. Today we'll talk about 37. In 37, this is where we're taking what we know about truth tables and symbolic notation, and we're putting it all together and we're like, when am I going to use this? When am I ever going to use this? What do I need to know about this? And so, what we're going to be looking at is or are statements like this. So this is an argument, and we want to know, is this argument valid? That if I have a conditional statement that is P to Q, and then I've got another statement that is the negation of P, then we can conclude the negation of Q. We want to know, is this a valid argument? Okay. Now, know that usually when you get into arguments and things like that, most of the time they're going to be sentences like this. So these are the kind of things that you're going to be seeing. Sometimes they'll give you the symbolic notation for it. Sometimes they will give you the information as words. So statement 1, statement 2, here is the conclusion. Okay. So if it is hot and humid, I complain. If it is not hot or it is not humid, then I can conclude I am not complaining. Okay? So, or something like this. If I tell you I cheated, I am miserable. If I don't tell you I cheated, I'm miserable. I'm miserable in conclusion. Okay? So we want to know, are these valid or not valid? Okay? So I provided you some notes. These are what they look like. They're right above this video. So first thing is, whenever we're dealing with validity of an argument, we need to express it symbolically. So you need to express the first statement in symbols, the second statement in symbols, and the third statement in symbols. These little 3 dots, they mean therefore, okay, or in conclusion. It's another way that these 3 dots can be translated. So usually I say therefore, but it also means in conclusion. We have 2 ways to determine validity. We can use a chart, which I have provided right here for you. This chart is also in your textbook, but I've went ahead and written it out for you and provided it for you right here. These 4 up here are all valid arguments. These 4 down here are all invalid arguments. Okay? So again, these are already known pieces of information. All right. So one way, once we have everything symbolically, we can come to our chart and see if what we're looking at exists on our chart. Okay. That's one way to know if we have a valid or invalid argument. Okay. We can look at our chart. But again, not everything is on this chart. Okay. So while the chart is great, not everything is on here. This is not the end all be all to validity of arguments. So the other way is we could use a truth table, and we could take our statements we have up here and we can turn them into a truth statement that we can validate or invalidate. And in order for an argument to be valid, in the end, it must be a tautology. That's important. So if we run a truth table, in the end, it has to be a tautology. So if you ran a truth table for these 4 up here, in the end, it would be a tautology. Okay? All these would be true in the end, no matter what. If you ran a truth table for the invalid ones, then you would have some sort of false answer somewhere. Okay? So in order to be a valid argument, in the end, if we run a truth table, it needs to be a tautology. Now, the one thing that you need to know in this, the chart's going to help you a lot. But if you, either way, if you use the chart, you have to know how to write this truth table statement. Okay, so on these 3 pieces that we're going to talk about, I'm going to be talking you through how to do this. And it's not too hard. Basically, all you do is you take the first statement and you put it in a parenthesis right here. So here's a bracket. It always starts with a bracket. Then your first parenthesis is the first statement. Okay? So this top guy that's right there, that's in the first parenthesis. Then you'll close that parenthesis and you'll put an and symbol. Okay? And then you'll write the second statement. and a parenthesis after it. Okay? And if we had more statements, then we would just continue in that fashion. And then statement 3. And then statement 4. And statement 5. And it keeps going and going and going and going. Most of us, we're just going to be dealing with the 2 statements. Okay? We're going to have statement 1 in parentheses and statement 2 in parentheses. And then you're going to close the bracket. Okay? So in the brackets go the top 2 statements in parentheses separated by an and. The therefore symbol will turn into a conditional. So this right here was the 3 dots. The therefore symbol, which was the 3 dots, these guys, turn into a conditional, an arrow. And then after the arrow goes the final statement, the conclusion. Okay? So this last statement right here is the conclusion. That's what goes after the arrow. All right? So let's do this. Let's take this statement right here. It's already in symbols. Go ahead and turn that into the symbolic information we have right here. Turn it into the symbolic statement that we could run a truth table on. And go. Okay. So hopefully this was the first thing you did. Bracket. And then we're going to open up a parenthesis, and we're going to put our first statement right here inside that parenthesis. Okay? So this first statement goes inside the parenthesis. P, arrow, Q. Close it. Put an and symbol. Open another parenthesis. Our second statement goes in here. Negate P. Close it, bracket. And that's what it looks like. Now, please understand, this is correct the way it is written, but my math lab will count this part wrong right here. Right over in here. The reason why it will count it wrong is because you put parentheses around a single statement. Okay? This is a compound statement. This is a single statement. Remember, we talked about this in the dominance of connectives. We do not put parentheses around single statements, although it's not wrong. This right here, this negation P, needs no parentheses. Okay? If you put parentheses around this in my math lab, it will count it wrong. Okay? Although it is not wrong having those there. It is technically not wrong. But in my math lab, it will count it wrong. So again, we're going to go back to what I've reiterated earlier. In dominance of connectives, do not put parentheses around single statements. Okay? All right. So the therefore part becomes the conditional arrow. And then last but not least, the conclusion part goes after the arrow. And that is what you will have to put in the blank for some of your answers, because it'll be multiple choice. It'll say valid, invalid. And if there's a blank after the statement, this argument is valid, this is what they want in that blank. Okay? I guarantee you're going to see this on your test. So in that blank, this is what you're putting. Okay? The statements in the top go inside the brackets, and they should be in parentheses unless it's a single statement. The therefore becomes the arrow. This part becomes the conclusion. Okay? So this is what they're looking for in that blank on those multiple choices. After you select one of them, this is what they want in that blank. Okay? All right. So now that we know how to do that, let's talk about whether this is valid or invalid. Okay, I'm going to get rid of those little markings right there. So valid or invalid. The cool thing is we can take this and let's go see if this is on our chart. So we're looking for P arrow Q, negate P. So obviously it's not going to be, Let me scroll up a little bit to get everybody. Obviously, this is not going to be these guys, the transitive, because P arrow Q, Q arrow R, we only have one P arrow. We know it's not going to be the disjunctives because this is ors, okay? We have conditionals. So we need to look at these guys because this is P arrow Q, P arrow Q, P arrow Q, P arrow Q, okay? So if you look at this, we need a P arrow Q negate P. So if we come up here, that's negate Q. Here, P arrow Q negate P. It says conclude negate Q. Hey, it concluded negate Q. So this, all these symbols match in my chart. So now I know exactly what kind of argument I'm dealing with. We're dealing with the fallacy of inverse. I don't care if you know that name or not. But what you now know, since it is this case that's right here, we know it's invalid. So we don't really have to run a truth table on this. We already know this is an invalid argument. So we would select invalid, and if there was a little blank after the invalid statement, I would put this information in right there. Because if we ran a truth table on this, we would see it's not a tautology. Okay? So that's how you use the chart. Take your symbols and see if these symbols match one of those cases exactly. If it doesn't, if it's not on this chart, then you need to run a truth table. Okay? And you would run the truth table on this. Remember, brackets are the same thing as parentheses. All right? So, let's walk through this one, and then I've got one right here that you'll try on your own. Okay? So, first things first, we need to convert these into symbols. So, I see an if, that means there should be a then, and it's right in here. So we know that this is going to be my arrow. Okay? And it's also got the comma by it, so I know this is the most powerful. So up in here, we have it is hot and humid. So this is a P and Q. And then over here, I complain, that's an R. All right, so what this looks like then is P and Q, arrow, R. Okay? So, because we know this is the strongest, because of that comma, we know that we're going to put parentheses around the beginning. So again, that's just stuff that we already know how to do, converting statements into symbols. The next statement, it is not hot. Oops, that should be a block. Actually, let's do this. So that's negate P, because hot was about P. Or it is not humid. Humid was Q, so that's a negate Q. So here we have P or Q. So in the end, they want us to conclude I am not complaining. So that's a negate R. So that's what we're working with. Obviously, if you go to our table, you're not going to be able to, you're not going to be able to see this on our table. Okay, it's not there. But what I want you to do real quick is go ahead and pause the video and turn this into a truth statement that we can use a truth table for. Okay, go ahead and turn this into its truth statement. Okay. So hopefully you turn this into the true statement, which will look like this. You're going to start with a bracket, okay? And then you'll have your parenthesis. And then we're going to put on our first statement. That's in red. P and Q in its own little parentheses because it's got to match arrow R. There's the first piece. Okay? Because in the first parenthesis goes our red statement that we had up above. All right. Now, we continue on. We put in, I believe it's and, right? Yeah, and. And parenthesis. Now we're going to have our green statement. And we do use parentheses for this because this is not a single statement. Close it, bracket. Okay? So there's our first piece. Okay, those are all of our statements. Now, what does the therefore turn into? Turns into the arrow. And then after the arrow, you put the conclusion. Okay? So, now, because this was not on the chart, you would be running, excuse me, you would be running a truth table. Okay? And if you ran a truth table, you'd actually have 3 statements. But I'm going to go ahead and tell you that if you ran a truth table for this, it's invalid. This is an invalid argument. In the end, it would not be a tautology. I don't really want you to run the truth table on this. I think that would be silly. My main concern is, could you put it into these symbols? And could you write this up for me? Because the ones you're going to deal with when it comes to your assignment and when it comes to your quiz and test, they're not going to be 3 statements like this. That's just silly. That's just too long. But this would be the truth table we would have to run with. Okay? Lots of stuff there. But I went ahead and told you it's invalid. If you want to do your truth table and run it, you'll see that it's invalid. You will have a false answer somewhere in the end. Okay? All right. So now this one, I do want you to run the full gambit on. Go ahead and do this one. And go. Okay. So hopefully in this one, you found out that this is valid in the end. Okay, so let's verify this. Let's run the full gambit. We're going to use a truth table on this. I'm sorry, you're going to have to, but it's only 2 statements that we're working with. So if you look up here, I see an if, that means there's a then, and it's right here. Okay, so I tell you I cheated. That's P. The then is the arrow, and I am miserable. That's Q. So this is P, arrow, Q. Okay, down here, there's an if. That means there's a then, and it's right here. So this is the arrow. I don't tell you I cheated. So that's a negate P. I am miserable. That's Q. So negate P, arrow, Q. And in the end, down here at the bottom, it says, I am miserable. Let's change that color up. Therefore, I am miserable. So that's Q again. So, again, that's not on our table. It's not on you're not going to find it anywhere on there, but we do have to run a truth table. And this is not that bad to run a truth table on. That's why I said do the full thing on this one. So, your statement would look like this. Bracket, parenthesis, P, arrow, Q. Close the parenthesis, and parenthesis, negate P arrow Q. Close the parenthesis, close the bracket. So there's our two statements in parentheses separated by an and. The therefore becomes an arrow and then Q. So that's what we're going to run our truth table on. Okay? So we got P, T, or sorry, not P, T, PQ. And since we know this is valid, in the end, this better come out to a tautology. All true. So we got true, true, false, false, true, false, true, false. So the first thing we need to do is our parentheses. So I'm going to start with the red one. So we're just got to take care of that conditional. P arrow Q. So remember, conditionals are only false when the antecedent is true, the consequent is false. So P is the antecedent, Q is the consequent. So true, true is true. True, false, that's the false case. False, true is true. False, false is true. So there's our first parenthesis. Next, we're going to take care of our second parenthesis, but I need to negate P first. Okay? And then I'll be able to take care of the full parenthesis. Okay? All right. So negation of P is false, false, true, true. So true to false, this is our false case. True to false, this is our, or sorry, I'm looking at the wrong ones. Woo! Mr. Armstrong about mess this up. This is the antecedent. This is the consequent. So see why it's always good to put that information down. So we got false to true. That's true. We got false to false. That's true. We got true to true. That is true. And we got true to false. And that one's the false one. There we go. Man, about messed that up. So now we're at the end. All we do is we're going to do the whole thing. Okay, now this is a bad habit. Please do not do this, but I'm going to put WT. WT does not stand for white trash. It stands for the whole thing. Whole as in WHOLE. Whole thing. Okay, this is bad. You should be writing the full thing out, but I don't want to rewrite this all out because I'm lazy. So I put WT for whole thing, not white trash, just so you know. All right. So in this one, oh man, again, Mr. Armstrong's almost messing up. I'm trying to rush everything. We can't do the whole thing yet because Mr. Armstrong forgot to do the and. Silly me. So we need to take care of the and between our two parentheses. So P arrow Q and negate P arrow Q. And then I can do the whole thing for the next one. All right. So then we can take care of this. All right. So let's do the whole thing. Remember, ands only true when both are true. So we've got true, true. That's true. We've got false, true. That's false. We've got true, true. That's true. We've got true, false. That's false. And there we go. And now we're ready for the whole thing. All right. So the whole thing, this piece is the antecedent. And Q, again, is the consequent. So we're going from true to true. That's true. We're going from false to false. That's true. We're going from true to true. That's true. We're going from false to false. That's false. Hey, oh, sorry. False to false is true. Mr. Armstrong and your mistakes. Sorry, this last guy, false to false, should be true. And you can see it's a tautology, which means that indeed it is valid, as we said. Okay? So again, turn these into the symbols. See if it's on the table first. And if it's not, run the truth table. But again, you got to make sure that you know how to write this information out. So how do I take this argument and turn it into a truth table statement that we can run? Okay. First statement goes in the first parenthesis. Second statement goes in the second parenthesis. Therefore becomes an arrow. And then your conclusion. All right. And that is 3-7. Have fun.